The objective of this demo is to demonstrate how system simulation supports heavy equipment manufacturers in increasing the productivity of their machine while containing the fuel economy. An excavator is chosen for this case study. The first step is the modeling of the current excavator in order to build the basis of the comparison between the original excavator and the new evolution of the product. The model of the excavator here includes the following parts. Combustion engine. The model objective is machine integration for fuel consumption and emission analysis on driving working cycle. So it's mainly map-based with performance, torque generation, and fuel consumption in function of the different working conditions of the engine, speed and load. So hydraulic actuation system model is based on a mix of functional and geometrical information for the components. Typically for the pump, they are mainly functional with information such as maximum displacement, volumetric and hydromechanical efficiency, and functional models for controls. Directional control valves are mainly functional as well, including flow rate, pressure drop characteristic, as well as valve dynamics. Cylinders, at the opposite, includes mainly geometrical information such as diameters and stroke. Pipe and hoses can be also simulated, rigid pipes, but also flexible pipes, considering the material elasticity. The mechanism model is based on rigid bodies connected by ideal junction. Penetration efforts can be also estimated when bucket moves into robots. Control for operator action can be defined using a sequence, using a state chart environment. So here the different phases are described, and an activation sequence of the different flow control valve is defined and parameterized. Now let's have a look at some results. Cycle time and energy consumption. What we see here is the displacement of the boom piston. So we can access by looking at we can have a look at the time it requires to perform a cycle, roughly 23 seconds, and the energy that is required or the fuel consumption required to perform this cycle, here in terms of fuel consumption in grams. We can also have access to the losses, the power and energy losses into the system with a specific tool. Let's plot the main losses of the system and try to analyze. The main losses of the system are related to the friction, mechanical friction inside the hydraulic cylinder. Could be interesting, so to try to reduce these losses by specifying to the supplier new components with less frictions. Some other losses, occurs in the swing function. Let's analyze in more detail. To rotate the excavator, an hydrostatic transmission is used. Here. When the excavator has to rotate, the pump delivers flow, and this flow is transmitted to the hydraulic motor. When the excavator starts rotating, part of the flow created by the pump is released to limit the pressure in the system. Here. So part of the energy is lost. Also, to stop the rotation, here, the pump displacement is set to 0, and all kinematic energy accumulated is released in the hydraulic circuit and is completely lost. To avoid such waste of energy, two technical solutions are possible, either to store the energy in an hydraulic accumulator or to completely remove the hydraulic system and replace it by an electric system. The model presented here is exactly the same as the previous one, except that the swing function has been electrified. An electrical generator is connected to the combustion engine. It generates electricity when the rotation is required. The electrical current is consumed by the motor, which generates the rotation. Let's have a look at some results here. The interest also of such technology is that during braking phase, here, the motor becomes generator. The system has been sized so as to reduce the cycle time while maintaining the same energy consumption as the conventional excavator. So now let's analyze the results of the conventional excavator and the hybrid excavator. If we look at the cycle time and energy consumption, again, the cycle time of the conventional architecture is roughly 20 to 23 seconds, 23 seconds for an energy consumption of 4.5 megajoules. And for the hybrid excavator, the cycle time is 21 seconds for an energy consumption of 4.4 megajoules. So globally, an increase of productivity of 10%.